All right. Hello, Professor Siegel. Welcome to our Thermo Project. I'm Franklin. This is Tyler. Where I'll go over the stuff. So our problem definition is that we need to create an energy storage system that uses solar energy in order to supply at least 50% of a home's daily heating usage in Pennsylvania. And so for our concept, we thought of using solar water heaters in order to capture energy and then use that water to heat the house. And we do so by using a pump and piping throughout the house in order to circulate the water and make sure everywhere in the house. Additionally, we're not going to use any insulation for the piping, as we can see on our next slide, that the entire house is our system, which means that any heat loss from the pipes, by not insulating them, will just simply just go into the system itself, which means that it will fulfill its purpose anyways. So to figure this out, we found that an average winter day in Pennsylvania has 2.78 hours of sunlight. Then assuming that the sun has an average of 1,000 watts per meter squared, we can figure out we can calculate the energy a square meter of water can give us by multiplying it by the efficiency of the solar water heater. And then we find that we need to provide 28.82 kilowatt hours per day. I will go over how we got this number later. And then since we have that number, we can calculate the mass water needed by dividing the energy we need a day by how many degrees of water we are heating the water by, which is only going to be 10 degrees. And then additionally by the specific water. And from there, we can get the mass, we can convert it to meters cubed, and then into gallons, which we found to be 63 gallons of water.
All right, so for our heat delivery design and specifications, again, we're going to use a simple kind of pipe design and pump to circulate the water throughout the ceiling and throughout the floor of the house. And again, these pipes are not going to be insulated because all the heat that's lost is just going to go into the house where we want it to go. And then we researched the average square footage of a house in Pennsylvania, and it came out to be about 1,700 feet squared. And then we did a calculation where we would need 425 feet of PVC pipes, assuming that there would be a spacing of about 4 feet in between each pipe under the floor and in the ceiling. So for our performance analysis, so our average, so we researched the average energy spent we based this off of natural gas in Pennsylvania, came out to about $740. And then we found out how much that would equate to in energy per year. And then from that, we found out that the heating season was about 210 days. So we divided that number by 210 and then multiplied by 50% to come to our 28.82 kilowatt hours per day. And that was the number that Franklin was talking about earlier. So then with this 28.82 kilowatt hours per day, we could divide that by the energy from 1 meter squared of the solar water heater. And that would tell us basically how many solar water heaters we would need. So we would need about 13 meters squared of the solar water heaters. And then we found the energy usage of the pump by multiplying a 1 horsepower pump, which is equivalent to 0.7457 kilowatts times 2,100 hours, and that's equal to 1,566 kilowatt hours. For our savings and our cost analysis, we're going to be spending about $740 per year on heating based on our research. And then we just divide that number in half. So our savings per year would be about $370. And then with the payback period of 10 years, our savings by the end should be around $3,700. But with all of our expenses, which I'm about to go over, we're going to have a pump that's going to cost $251. And then that pump's going to use about $282 per year of energy. So that's kind of a lot. And then the solar panels cost $352 per meter squared. And we're going to need 13 meters squared of them. So that's going to come out to $4,576. So that's definitely not good. And then the pipes, which are going to be PVC, are going to be $552, and that's for like 400 to 450 feet, as I said before. And then so it's definitely going to take more than 10 years to pay back if we buy the panels. So it's not very good. And then for our conclusions, basically the solar panels are pretty expensive, and it's definitely not going to be worth to install our system if we want to make our money back in 10 years. But for some improvements, we could try to make our own water solar panels. And it might be a little bit more cost effective. And we could also invest in a small solar panel to harness some of the power for the sun to power the pump. And then we could also consider using a phase change material instead of water inside our system to be a little more efficient.
All right. Thank you.
Thank you.